Says it's the quotient. All right, guys, let's get started. This is from assignment 4-3.
Is it recording?
Yeah.
33 through 40, and I'm just taking my bag. I won't do everyone if you don't want me to do everyone, but if there's something on there that you are struggling with, then I will be happy to help.
Hi, Kim. Oh, yeah, we'll start.
What did you do?
Number 33. I have a question about number 33. So number 33, does it say tangent of theta, cotangent of theta?
Yeah.
All right, I'm going to use x's instead of thetas, so it's easier, quicker to write. And we have to try to make the left side of this thing equal to 1. So this is when that pink paper that I printed for you guys might be helpful. What are tangent and cotangent of each other? The reciprocal functions. So if I were to rewrite cotangent as 1 divided by the tangent, the problem's done. Tangent really means tangent over 1. The tangent on top, the tangent on the bottom, they cancel out. What are you left with?
1.
1 over 1, which is 1. So 1 equals 1. That's it. So reciprocal functions multiply to give you 1.
Always.
What else can I help with?
234.
Number 34.
Let's do one more. Yeah.
Number 34, we have cosecant of x multiplied by the tangent of x, and we have to try to make that be the secant of x. Now, I think I said this the other day, I will say it again. When you're working on these and you're not getting what you want, doesn't seem to be headed in the direction that you want, then start over. Try something else, because there's not just one way to attempt these things. All right. Cosecant. What does cosecant mean? What's another way to write cosecant? 1 over sine. So I'm going to rewrite cosecant as 1 divided by the sine of x. Now, tangent, that's one of those functions where you could write tangent as 1 over cotangent, or you could write it like something else. What else can I write tangent as?
Sine over cosine.
Sine over cosine. And I think I said to you guys a while ago, tangent is often written as a sine divided by cosine, okay? So when you see tan, certainly don't rule that out. That is always a good option. I'm going to write tangent as sine divided by cosine. So when you multiply these two fractions and you have a sign on the top and a sign on the bottom, what happens to your signs?
They
Cross
cancel
out.
They cross off. What's left?
1 over cosine.
1
1 over cosine. What is 1 over cosine?
The reciprocal of secant.
It's secant. That's exactly what I wanted.
Bless you.
I can.
35. Try it. It's not bad. Tangent of x, cosine of x is equal to the sine of x. So, what I usually do is start with the long side, make it look like the short side. Don't start with the sine of x and try to make it equal tangent of x times the cosine of x. That would be silly. All right, so help me out. What can I write tangent as? Jared, what does tangent mean? It means opposite over adjacent. All right. What else does it mean? What she said.
That's
Very
what
nice.
she
Tangent.
Oh, gosh.
Sine over cosine is what he meant to say.
I think you're just doing
Times the cosine. Times the cosine of x. Well, the cosine of x, if it's just the cosine, I can write it as the cosine over 1, if that helps to write it like that.
cancel.
I'm multiplying, so what cancels out? Cosine. What's left?
Sine
Sine
or 1.
Sine over 1.
That's what I wanted. Sine of x over 1 is the same thing as the sine of x.
Yes.
Jacob, are you all right? Please don't ever do that again.
What do you do?
What do you do?
Oh my gosh.
What do you do?
36. Write it down, try it, you guys. Cotangent of x, sine of x. We're trying to make it be the cosine of x. So, Jared, what does cotangent of x mean? 1 1 over tan. What else does it mean? It is the cosine over the sine. It's the reciprocal of tan, right? And tan is sine over cosine. So cotangent is cosine over sine. So we have the cosine of x divided by the sine of x.
I think they cancel out.
You multiply that by the sine of x over 1.
Seems like a theme.
What do you get?
Cosine.
Cosine
X
X
over
Let's
one.
try it.
equals
I got a question.
cosine X.
A question real quick.
Yes.
Euler.
So we only switch the first one because you see you put the sine over 1.
Yeah.
Because here I have that sine equals 1 over CSC.
Yep. And sometimes it might be helpful to write sine as 1 over cosecant.
Okay.
Like I said, you might try one way, it doesn't work. Maybe what you needed, but I
When
knew.
it's positive and negative, right? That-
No, not because of that, but I just knew that when I have cotangent, I know I can write cotangent in terms of cosines and sines. So if I can write cotangent in terms of cosines and sines, why would I write sine in terms of cosecant? You know what I mean?
Gotcha, yeah.
But if I was starting with cosecants or something, then I would probably change sine to that. But you want to try to keep your sines and cosines and stuff the same.
All right.
Okay?
Yep.
Yes.
Is there more than one way to get the right answer?
Yes. Absolutely yes. More than one way. I would say in some of these to begin with, I don't know why you would do it another way, but some of them
Exactly.
absolutely you might see it completely different than the way that someone else would see it. So let's do 37. When you look at 37, can everyone have their stuff out in front of them, trying, following along, pretending at least? Number 37, you have 1 plus the cosine of x, and you have to multiply that by 1 minus the cosine of x. And you have to try to make this look like the sine squared of x. So I just want to take you, what if you had a situation like this, like x plus 1, and you had to multiply it by x minus 1. If this was what the problem said, what would you do back, when we were doing math? What's that thing? That thing called
Foil.
FOIL. Yes, you would FOIL these two. You would say x times x, and then x times negative 1, and then 1 times x, and 1 times negative 1.
Yep.
You're going to do exactly the same thing. So first of all, you're going to take 1 and multiply it by 1. What's 1 times 1?
1.
What's 1 times negative cosine of x?
Negative cosine of x.
Negative cosine of x. And now you're going to take cosine of x and multiply it by 1. You get
Cosine of x.
positive cosine of x. Don't forget your sine values. And then cosine of x times a negative cosine of x is going to get you,
Negative cosine squared x.
yes, negative cosine squared. Remember how we talked about putting the 2 there instead of at the end? It's not the x that's squared. It is the cosine of x that is squared. And for whatever reason, it is okay to write your 2 in between the cosine and the x. All right, what's going on here? What can I cancel out?
The positive and negative.
Yeah, we have a minus cosine of x and a plus cosine of x. They cancel right out. What are you left with?
1 minus cosine squared.
1 minus the cosine squared of x. Now, the other day, we wrote some identities down in our notes. And one of the identities was called, well, they're all Pythagorean theorem identities, but one of them, the most basic of all of them, was that if you had the cosine squared of x, and you added to it the sine squared of x, you would get 1.
Yes.
Maybe it says sine squared plus cosine squared on your paper. I can't, on your pink papers. I don't know if it's sine squared or cosine squared first, but whatever, it means the same thing.
Sine squared.
You're adding together the cosine squared and the sine squared. You should get 1. Now, remember how we talked about moving things around a little bit? And if you took the cosine squared of x away from the left and then do the same thing over here on the right, you would have the sine squared of x is equal to 1 minus the cosine squared of x. That is exactly what we have right here. What is 1 minus the cosine squared of x?
Sine
that what we wanted?
Yeah.
Yes.
Yep.
We wanted it to be the sine squared of x. So you're done. So on your test, I am going to have a couple of these, maybe 2, maybe 3. I'm not sure yet. I haven't finished that portion of the test yet, but be looking for things, you know, little stuff. So this is what you're going to have to do. Those kinds of tricks. And look at the last few that you have to do there. Is there anything in there? Well, there are some that we should talk about. Which one? Do all of them. All right, that's fine. We can do them all. 38. Look at 38, please. What are you going to do in 38? You're going to do exactly the same thing. FOIL it. Cosecant of x plus the cotangent of x. Multiply that by the cosecant of x minus the cotangent of x. And in the end, we want this left side to get us 1. Help me out.
Okay.
What do I do?
Let's spoil this real quick.
Boil it real quick. So we have cosine of x, excuse me, cosecant
X
times
squared.
cosecant. What is cosecant times cosecant, Jacob?
What?
What is cosecant times cosecant? We have cosecant squared of x. In other words, we went this times this. Now what do we do?
Times it by the negative cotangent of x.
Very good. So we have minus cosecant, oh my gosh, I wrote that wrong. Cosecant of x, cotangent of x. You okay with that?
It's ugly.
It is ugly, I agree. But
Yeah.
it's in a minute.
It's gonna
You
get
guys
us-
notice that these two things are exactly the same.
Yes.
The only difference between them is the positive and the negative. So they're going to cancel each other out, just like you just
I
said.
thought it
Yeah.
was a
So now we're
6.
going to take this cotangent and multiply it by cosecant. Those are both positive, so we have plus cotangent of x, cosecant of x. And then we're going to multiply cotangent. We did this one times this one. Now we do cotangent times negative cotangent. What is cotangent times cotangent?
Cotangent squared of x.
We have cotangent squared of x. Ignore that thing in there. All right, what can I do? What is there anything that cancels out?
Yes.
Yeah, these two things, even though this one says cosecant cotangent, they're still being multiplied by each other. This one is written in the opposite order. Cotangent of x, cosecant of x, they're exactly the same thing. So we have a minus and a plus. That cancels them right out. What are you left with?
Cosecant squared
Cosecant squared of x
minus.
minus cotangent squared of x.
Yes.
Isn't there an identity on your paper that says,
Yes, there is.
actually, is there?
Yep. I
1
think.
plus cotangent squared x
Cosine.
equals.
What did you say?
The other one?
Oh, you're talking about, that one, but I was talking about the.
Oh.
Can I see your paper?
Gotcha.
I don't have that thing in front of me.
Maybe you should. I did. Was it good?
Oh, yeah, it does. And you know what's funny is when I did this problem, that's not what I did. I totally did it the long, ugly way. I don't know why I did that. Cosecant squared minus cotangent squared. If you move things around with one of those Pythagorean theorem identities, you get 1. And no, I think those are in your notes. We moved everything around the other day. So 1 is equal to 1. Number 39. We have the sine of x divided by the cosine of x plus the cosine of x divided by the sine of x, and we need this to be the cosecant. I keep doing that. We need it to be the cosecant of x, secant of x. Yes.
Why don't we just put it tangent of x plus cotangent?
Okay. Sure.
But,
But then what are you going to do with it?
well, then you gotta do it backwards. No, and then undo it. So you can separate them out.
Okay, let's try that. I don't know if it's gonna work or not. And this is a perfect example of. Did you guys hear did you see what he just said?
No.
He said, well, sine over cosine, that means tangent,
Okay.
right? What does cosine over sine mean?
Cotangent.
It means cotangent. So if I could just rewrite these things as something else. Sine over cosine means tangent. So we have the tangent of x plus the, what's cosine over sine?
Cot.
Cotangent. And I don't know if this is gonna work or not, but we're gonna try it. What do we do with this now?
I don't know.
No, that's okay. Does anybody have any suggestions? I mean, we could write this now as the tangent of x over 1 plus the cotangent of x over 1. But I don't see where
That's
that's
why I
going to
said
get us
never
anywhere.
mind, because we'd have to undo it. But
So this would be, we probably have to try something else. So what I'm going to do is erase this. And we're gonna try something else. What I see up there is two fractions that have to be added together and they have different denominators. Would you agree?
yes.
If they have the same denominator, you would just keep the denominator exactly the same and you would add the numerators. But the denominators are different, so you have to do something else. Does anybody remember what you need to do when the denominators are different and you're adding them together? Yes, you cross multiply. Yes, very good. You're going to multiply this way, and then you're going to multiply that way. You guys, what is the sine of x times the sine of x?
The sine squared.
Sine squared. And then we're going to multiply cosine of x times cosine of x. What is that?
Cosine squared.
Cosine squared. So what we're going to have is the sine squared of x plus the cosine squared of x. What is that?
That.
Look at your pink papers. What is the sine squared plus the cosine squared?
1.
It is 1. That is something that you need to commit to memory.
Yes.
It is the Pythagorean theorem, just written in terms of trig functions. Yes.
Can't you like cross out sine on top of the first fraction and the second one, and then cross out cosine?
No, because we're not multiplying.
Yeah.
And then
That's
get one.
nope. You are because you're not multiplying.
Oh.
That is only true when you're multiplying. Okay. So when there is a plus sign, you have to multiply left to right. That's going to get you sine squared of x. You multiply bottom left to top right. That gets you the cosine squared. I forgot my x here. Divided by, what goes on the bottom? How do you come up with the denominator? You multiply the denominator. So on the bottom we have cosine and a sine. So you multiply cosine and sine. What's cosine times sine? It's going to be cos x sine of x. You just multiply denominator times denominator. What's the top? What is the cosine? What is the sine squared plus the cosine squared? 1. So we have 1 over
1.
cosine of x sine of x. Okay, this 1 is on top of both the cosine and the sine. Well, what is 1 over cosine? What is 1 over the cosine?
Cosine.
Secant. So 1 over the cosine is the same thing as secant. What about 1 over the sine? Cosecant. Isn't that what we wanted?
Yeah.
The only difference between what we came up with and what's over there is that they're written in the opposite order, but since you're multiplying them,
It don't matter.
multiplying is commutative, which means it doesn't matter what order you multiply in, you're still going to get the same thing. So I can say, well, that is equivalent to the cosecant of x times the secant of x. One more, number 40. We've got the tangent of x plus the cotangent of x divided by the tangent of x, and we have to try to make this look like the cosecant squared of x. Alright, so I have two things on the top that are being added together and divided by the same denominator. So let's separate them. Make them two separate fractions. since these things are being added and divided by the same thing, that is the same thing as writing tan of x over the tan of x plus the cotan of x divided by the tan of x. Do you understand what I just did?
Why don't we just do one?
Yeah, what is the tan of x over the tan of x? It's like having x divided by x. What's x divided by x?
Uno.
It's 1. Yeah.
Uno.
So tan of x, what is 5 divided by 5?
Squared.
One.
1 divided by
One.
So we have 1 plus the cotan of x divided by the tan of x. And we have to try to make this be
Cosecant squared.
cosecant squared.
Try that for the other ones too.
Any
make sure
ideas?
that the squared afterward doesn't affect it. Just because
What if you, no, just, well,
Cotan over.
what if you, wait,
Aren't these reciprocal functions of each other?
Yes.
Let me try this. 1 plus, I'm going to keep at the top cotangent of x. But instead of on the bottom having tan of x, how could I rewrite that?
sine,
Okay, sine over cosine, but I'm not going to bring in sines and cosines. I am going to try to write the tan as something else that doesn't use sine and cosine because I don't already have sines and cosines in here. Do you see how we already have a cotangent in the problem? How could I write tangent so that it has a
1 over cotangent.
Okay, very good. So tangent is the same thing as 1 over the cotangent. Try to keep in there what you already have. So I'm going to rewrite this as 1 divided by the cotan of x. Okay, so what I have going on here is the cotan divided by a fraction. And when you divide by a fraction, that is the same thing as multiplying by its reciprocal. So I'm going to rewrite this as 1 plus, I'm going to keep it cotan, but instead of writing divided by 1 over the cotan, I am instead going to multiply by the cotan of x divided by 1. So dividing by 1 divided by the cosine, or the cotangent, is the same thing as multiplying by the reciprocal. Are you okay with that? Alright, so what is the cotan times the cotan?
Cotan squared.
Cotan squared. I'm running out of room, so I'm going to head up here now. So I have 1 plus cotangent of x times the cotangent of x over 1 is the same thing as the cotan squared of x. Look at your pink papers. What is 1 plus the cotan squared of x?
Cosecant squared of x.
It is the cosecant squared of x, which is exactly
What we wanted.
what we wanted. So we have the cosecant squared of x is equal to the cosecant squared of x.
We did it.
I did it.
I did.